So, like, when I have been invited to this talk, I took the opportunity to look after certain aspects of SLAM that, or of how the SLAM technology is used, that are still kind of annoying me. And like, it's quite a while that I'm working in the field, so I think that I've observed plenty of behaviors or uses of the SLAM system that could be, in a sense, optimized. So let's start. I mean, I will not be telling what SLAM is, because I assume that everyone in the room knows, and probably someone else of the speakers will wrap it up. Anyway, in the past, I'm talking about 20 years ago or even more, SLAM was regarded as a hard problem, meaning that back then, as far as I recall, people were mostly concerned in localization. It was the geological era of the filters, Kalman filters, particle filters, and so on. And then the problem became consolidated, the problem of localization. And then people started looking into SLAM also, because they needed the maps for their localization systems. Nowadays, we are in a condition that we have effective systems now that work, open source systems that are able in general to provide a decent map. Now you see here two instances of SLAM running, like, which are developed within our lab. One is a visual SLAM system, the other one is a laser-based SLAM system, and well, they appear to be quite solid under typical conditions. The technology, however, has evolved, and so what I see now is that publishing a SLAM paper is even harder and harder. We try always to compete on the edge and to improve, like, some epsilon performance or benchmark on data, that, and the situation becomes harder and harder. I mean, on the other hand, there are now SLAM systems that are in place. Many of you are familiar with Ubering robots, or even Intel recently, a couple of years ago, started a line of RealSense, and they produced this fantastic device over here, the T265, that it's basically a very neat omnidirectional stereo inertial camera that implements on board a visual odometry system, which is exceptionally robust considering the size of the device. And it costed actually like around $200. The problem, unfortunately, Intel has dismissed this line of products recently, so that was a little bit of a shock. Because I believe that many SLAM, like many companies or many SLAM users, many SLAM people, they still like to do their own things, and so like maybe they didn't have enough market. Now, but anyway, this is to say that SLAM systems are now effective in action in industries, and well, they are consolidated also with products which are sold to many people. Now, what typically we SLAMers offer to the community or to our, let's say, users is a couple of things. We have a SLAM system to build a map, and then together with it, we offer a localization system. I don't know which sort of trick we have made in the past, but we convinced many people that they need SLAM, while most of the mobile robot applications, actually, they could perfectly rely just on localization. Like everyone says, oh, we need a SLAM system for a robotic Uber. No, man, you need a map, and you need a robot that can localize in that map, right? Anyway, this is what we convince the community of very often. And so the common scenario, I don't know how many of you have seen this pattern repeating, is the following. There's a new environment, a new place, a new experiment to be done, the first thing that people do is like be sure that the map is right. I'm talking about an experiment which involves mobile robot navigation. Have a map, have it nice, because then everything else is gonna be like work well. Then you go around with your SLAM system, and then very often the people ask, hey, how was the map? Normally in the groups there is this map expert that comes out and is the one that knows the algorithm and steers the robot around because he knows how to steer the robot. Then you get this map, you're happy with it, and then you conduct your experiment, and then you trash the map. This is like what normally you do, and also what several products like hoovering robots do now. No, like every time you start them, they construct a new map. There is some recent model that remembers the map from the past, but most of the time you just like get a map, navigate on it for 1, 2, 3 days, and then you trash it away. There has been work also by Tom Duckett, also by Tomek here, Thomas, that worked on this in this field on how to reuse like the map. Like the problem is that in the previous pattern there is a waste, because every time you do the same thing over and over again. You take a map, you capture, you invest effort, you steer the robot around, which first time is fun. After 10 times you do it, it's not fun anymore. And then in the end, always in the same area. Like if you're kind of bothered of doing that, you might focus on the topic of map maintenance and on analyzing this data to determine like how the map will evolve over time. So we're moving from acquiring a map at every time to having one single map and then improving it over time or keeping it up to date. A classical pattern or a potential way of doing this is to acquire an initial map and then to have a system that runs in localization mode. And then whenever there is something substantial that it changed, then it tries to refine, to readjust this map. How it's made, it depends on the particular implementation. Now, in all this process, or in this re-slamming process, there are some downsides. Let me say that it's impressive how much our computers consume now, and how much the algorithms consume. Now, if you would buy a wattometer, one of these devices that you can plug between the electricity, the power network and your computer, you could actually observe how much a tab of Chrome or a tab of Firefox consumes. We're talking about 10 watt of energy for a probe. And I'm looking in that direction because here I have 2 monitors, and then on this monitor you are, and on this monitor is the presentation. So sorry for giving you my left side. But in general, like we are running more algorithms than what we need. And SLAM is much more complex than localization in general. So like if you would have platforms, robots that just like run the minimum that they require and they rely on the same map, I believe that we could do something good for the environment because the program will be simpler. And I really like simpler programs because they are less error prone. That's less things that can go wrong. And then in addition, like aren't we bored of reacquiring the map over and over before every experiment, of calling our map expert because the parameters need to be tuned a bit to get like the optimal result? I mean, this is something that I believe could be avoided. Another aspect that bugs me is that that even if we would have acquire the map once, and this map is decent enough, the environment is static enough so that we could use it for quite a long time, then it's just sufficient that we mount a new sensor on our robot, a new device, and then the map that we had like is no longer usable because there are new cues, new things. Imagine that you have a robot with a laser scanner, then you mount a camera, then well, it's not immediate how to use the the previous map. So you could just decide to rerun a different SLAM algorithm that relies on vision, then try to register the two maps, or the one obtained with vision and the one obtained with laser, just like to have a unique representation in the game. So the downside of this approach will be limited platform portability, and then the fact that actually in most of the times you don't need to acquire a new map. You just need to use the map that you have acquired before, eventually amending it. So like in general, I see the actual use of SLAM as wasting of resources, like despite the initial mapping, wasting of energy for the computation, wasting of data, because each time you get this new log, this new data set, you throw it away. And most importantly, it's a waste of time because, because of the reasons that I've listed here. So you have to acquire a new map, the new data, you have to go around, you have to tune your algorithm. And then imagine that your system is integrated in something larger, like where you had to do some sort of labeling of the rooms in the environment, right? Like then every time you acquire a new map, then you need to redo the labeling, redo subsequent work. Like this is the bedroom, this is the living room, and so on. So then what if we could have lighter algorithms running on our robots, not one, many of them, you could imagine. And that this would result that we have longer autonomy for the platforms because they consume less energy, besides doing good for the environment, which is also a nice thing. Also, imagine that you have a SLAM system, an infrastructure where when you add a new robot, you just like put it in a place and you don't have to do nothing. Like the platform is gonna work. Regardless, it has all sensors, like sensors which are compatible with the existing map or not. Only, of course, it has to run some common software, but this is the minimum. Accordingly, if you would have such an infrastructure, this means that you could port all the work that you have done on the maps before, maybe some manual labeling, whatever you have done before. Then, given that the map doesn't change, it gets only augmented with new layers. You could like do less work. Well, I believe that this would be cool, and then this is my, let's call it vision, or my I believe it's the idea of many, of seeing SLAM as an infrastructure. So of moving the computation and the effort of SLAM from the robot, where it actually is, to some sort of SLAM box that someone could install into his facility that then talks with the robot, that runs just a minimal amount of software. This system just like records or like is aware of the data that are gathered by the robots and tries to construct a consistent map. How is it? It is done. Well, let's say that a potential scenario would be the following: you buy your new platform, like this one over here, all hand built. You put it in your room, and then you steer it around, and you basically this robot sends the data to this mapping box that then at the end will have his own representation of the map. So the first exploration round, the first mapping round, you have to joystick your robot. But what if this would be the only time that you joystick your robot around in order to get the map, unless, of course, dramatic changes in the environment? Then once the system has to use the map, shall it be the same robot or another robot, it just like asks for the map to this infrastructure. Note that this can be easily implemented with the existing tools that we have in ROS, right? Like we have a map server, you load the map server in the system, and then everything basically works this way. But then after that, what you typically have is that you can steer the robot around, it can navigate, it can do its own fancy thing. However, the problem comes when you want to give to your system a new sensor. Maybe because, I don't know, before you were focusing on planar navigation, then you want to deal with overhanging obstacles. So like you're going to add a camera, you're going to add a Kinect or something on top that is able to get the 3D structure. Well, what could we do in order to reuse the maps in this case, and what the system has to provide? Well, let's think to the simplest solution that we could use in order to have this labeling would be, if my robot is being extended. So if we are adding a new sensor to the robot, we could easily reuse the localization system of before in order to track the camera position, then sending to the robot a map, recording the image stream, and then potentially annotating the map with the images or with the features or with whatever the new sensor provides, right? And this would add a new layer to the map. This is easy, right? Because it doesn't require a monster computation that could be entirely handled by the mapping box that should just like be aware of the new sensor stream being produced. Now, and this is also easily done from a programmatic perspective. What if we would like to add to our system instead a new robot that has nothing to do with the previous one? So like before we had the robot with a laser scanner, then we had the robot with a laser scanner and a camera, but let's assume that we do not have the dual robot configuration. And we have only a robot with a camera. Like what could we do? Well, in order to fuse the two representations, the only way is to register the two maps. So by using off-the-shelf components, what we could do is to steer our robot around, again, steering, right? Steering robot around. And run some sort of SLAM pipeline, let's say OR-SLAM or whatever, which would provide us with a nice point cloud of the features. And then once we have these 2 point clouds, we might want to register the two maps. So like saying, oh, you know, like this image or this point here corresponds to this point here corresponds to this point here. So like you have some sort of manual labeling of the places that will allow you in the end to register the two maps. Again, this involves work. Another alternative is that you use some markers. Then this would save you from the manual labeling. So you could decide to put some, let's say, QR code or something that you hand label in the laser map. They are detected in the visual map, and then the two gets registered. It's manually solving the data association problem. But also, we're talking about adding a new robot, right? Another potential alternative in using this infrastructure is like, okay, I have two robots, the one that I originally used to acquire the first map, and I have a new one that has a new sensor setup. All I need in order to have the two maps in the same reference frame is to steer one robot while the other one is following, and then I will have an implicit localization of the second robot with respect to the first. So one could just like imagine of putting a QR code, for instance, on the robot number one. Once you add a new system, a new device into your house, you say, oh, buddy, show the other buddy like how the environment is. And then the process could be, in a sense, automatic. Okay, because then you will have the first robot that patrols around, the second robot that is following the first based on some sort of visual server, and then you will have a stream of registered images that will in the end constitute the initial map. And then this would result again in less effort on your side. You have a new robot, all you have to do is to initiate the leader-follower procedure. Now, all these problems, all these aspects are a little bit aside from the SLAM technology, but still I believe that there is some research to be done in order to build an effective system. Well, if you want to build something that actually works well and works on a large scale, there's something that you have to address, and then you might want to focus on clearly the energy, on the bandwidth used, because we all know how brittle is the Wi-Fi, how brittle are the networks, and then you don't want to have a system crashing just like because the stream of sensor data doesn't work. There's a whole lot of work which has been done also by someone that is by people that are attending on this workshop, which is on map maintenance. Like if the system has to work over and over, and if you just want to acquire the map once, then clearly you'll have to deal with the dynamics in the scene. you will have to deal with handling faults, because it's unavoidable that sooner or later one of the systems in your pool will crash. You'll have to deal with how to add heterogeneous sensors, how to manage to find common cues between maps acquired or between sensor data acquired with different sensors. And also you'll have to reason on how the maps evolve over time, maybe leading to predictive models. Another aspect that is quite relevant is like having a system that works over multiple sessions. Imagine you have multiple of these map boxes, or even one, but that the environment is quite large. Well, then it might become annoying or impractical to acquire the map in only one go. And you might want to map a city or like you're building one floor at a time, or refining the area one floor at a time, or you build a new wing, and well, then there will be some extension to be done to the classical SLAM paradigm, also looking on to what happens over time. And the final thing that I'd like to stress is that I'd like not to steer a robot myself anymore, because that's what I've been doing since 20 years. Like, I'd like to put a robot into the room, load some software, because that's what I do for a living, and then let the system evolve and not care about registering the new map. So I'd like to avoid redoing the same work over and over. Well, just to conclude the talk, I think I've been faster than expected, or not. I'd like to point the attention to the fact that several robotic applications, they do not require SLAM. They do require only localization on an up-to-date map. Seeing SLAM as an infrastructure, which is something external that doesn't have to run necessarily on the robot. On the robot, we need localization. We need some sort of reactive behavior for doing, for not being blind or not working in open loop too long. But we rarely need a map. Will allow us to save work. We could have plug-and-play systems. We could save energy, because we don't need to run expensive algorithms over and over. The system becomes more simple. Overall, a system, I mean the SLAM system plus the fleet of robots potentially, which means that less bugs are there. And I believe also it opens some interesting problems that might be interesting for us. So that's it. Let's conclude my presentation. And I'm happy to receive questions.
Thank you very much, Giorgio. Very nice presentation, very interesting presentation. So, are there any questions?
Okay.
Please, if you have any question, please just write in a chat something, like even one letter. Okay, I will start then. You gave quite a long list, I would say, of things that bug you in SLAM, and I have to admit that I share all of them, even if I didn't know about them before you gave it. I think that I have exactly the same problems with SLAM and mapping community. Oh, sorry. I see that I have, there are two questions there, so please, Matteo, can you spotlight the first question, and then I will get back to my question.
Shall I go away from the spotlight spot, or shall I stay there? No,
you stay. You stay.
I stay.
Okay,
I'm Matteo.
Coming.
Yeah. You have to go on the stairs.
Yeah.
No, you don't have to. You are just, you can sit in your place.
Okay, do you hear me?
Yes.
Yes, I hear you.
Okay, first of all, thank you for the presentation. And I have a question about what you said about the performances of reusing a map in SLAM systems. So I can easily understand how for vision or radar system, the use of an existing map would be incredibly helpful, both in terms of performance and accuracy. But what about laser-based SLAM system? So, for example, systems which use both feature-based methods for tracking or full point cloud scan matching. So I don't see how a map, aside from a more accurate realization of the map, would improve the performances and the operability of the robots.
Okay, let's imagine that you have, okay, clearly if you have a map that, this is what I provided is just an idea, an implementation. Like the idea would be to have a multi-layer map on which, of course, you could use the best layer that is available. So imagine that you have a fantastic SLAM laser, like 3D laser-based system, and you have a robot with a 3D laser. But inside this environment, you might also have a robot which is cheaper, which just has a camera, right? And you would like to have the two systems to interoperate. So this means that in your map, you need to have both visual cues and laser cues. So, of course, if you have already the optimum, that's not much, like you stay where you are. It's like useless also to improving what's already working. At the same time, there's also, if you can't improve something expensive, you try to do something cheaper. And so you might want to have a stupid robot with a monocular camera and wheel-based odometry that is able to navigate in this environment. And to this extent, maybe imagine all the labeling that you have done, or maybe automatically that the system has done, in order to find a traversable surface onto the dense point cloud or dense mesh map that is obtained with the laser, that could be easily ported to the visual, to the robot with a camera, right? Without having to say, oh, you can go here, you can't go there. So having multiple layers, like also for different sensing abilities. Did this answer to your question?
Yes, thank you.
You're welcome.
Okay, thank you very much. And now the second question. I think that Magnus is the second in the queue.
Yeah. Yeah, thank you, Giorgio, for an interesting perspective.
You're welcome.
I was just wondering, you said that what you need on every robot is really just localization and not SLAM. And I partially agree, but I was thinking that there's always this problem that eventually the map will be outdated, right? There will be more and more changes compared to the original map. So shouldn't you have localization and some kind of detection unit that can trigger a reacquisition of the map? So don't you need more or less 2 units for that?
Yes, I mean, well, thanks for the question. Like perhaps I wasn't completely clear. Like what I expect is that I need to have an initial map, and I need to have that the units, the robots, just upstream that data, and then on the mapping box there will be some sort of consistency check that will decide whether to update a map or not. The thing is that
so you think of that as part of this SLAM infrastructure that is available.
Exactly. So there will be the need. There isn't any time, but the point is that you don't do it if it's not needed. But if you see that something has dramatically changed, but then also, is it going to be a fault because the robot is lost, or is it going to be a change in the map? That's always tricky to determine, just like by looking at the sensor data. Yeah. If you have access to an entire system, maybe you could send another robot there to see, hey, let's see if that bastard was lying or not, right?
Mm-hmm. Okay, thank you.
You're welcome. Thanks for the question.
Thank you very much. And we have one last question. I think it's from Max. So Max now is in the spotlight, so you can ask your question.
Hi, Max.
Okay, I will just read it out then. Wait 1 second. Okay. Yes, I will just read it out then. So the question was, So the question was a quick question towards the uncomfortable data protection. SLAM as infrastructure is interesting, but the case of an Airbnb apartment may be a good counterpoint, where this is not desirable, at least not for vSLAM. What do you think?
Yes. well, I will try to give two ways of tackling this problem of privacy, which is kind of reasonable. The first one would be you could protect the data directly from the source. Meaning, what if your system doesn't shoot an image stream, but just shoots some sparse features that will not then allow to reconstruct the 3D dense thing on the one hand. On the other hand, the reason of a map box would be to have a map box which is sealed inside the apartment and doesn't have any, let's say, outer connection to the world. Like, but that's definitely actually like we now have Roomba in the house, and we don't know what Roomba is doing, but Roomba is a camera, so like Roomba could violate the privacy. Only that we trust the producer of this robot not to trim our inconvenient images over the web. But privacy is an issue. One idea would be just to produce data that are good for SLAM, but that they are not good for, let's say, they don't break the privacy, so to say. Mm-hmm. A bunch of 1,000 visual features every meter, well, will hardly let the people to reconstruct the 3D dense structure of the thing. And also this is compliant with the fact that we want to have limited bandwidth, right? And so like it's much cheaper to send these 1,000 features, but this would be a specific aspect. I mean, as developer at the beginning was that we try to develop the technology, but I believe I agree with you, Max, that privacy is always a concern.
Okay.
Did I answer your question? I can't read the chat. I don't know where to read it, actually.
No, it's fine. I will handle that. So, Max, do you think that the question is answered? Yeah, thank you. So let's say one last question from Francesco.
Oh, okay. Can you hear me?
Where are you?
Can you hear me?
Yeah, I can hear you. I can't see you.
Okay.
I'll leave paging you.
Now it's good. Now you should be in Spotlight. So now you should.
Okay. Anyway, so I see some parallel with the between the problems that you have outlined for SLAM with some of the problems that there are in the big field of the machine learning. So you build a model and you sometimes use this model just once. And in that field, there are some techniques that have been developed for like transfer learning, like domain adaptation, and so on. So the question is more a curiosity. What is the connection between the two fields, like SLAM and machine learning?
I mean, let me say that normally nowadays SLAM is mostly model-based, because the certain aspect of SLAM are model-based, which is the opposite of machine learning. You open the model and then you put inside all your physics or all the things you know in order to solve the problem. Machine learning tries to do the other way around. Like I'm completely model agnostic and I train it with a lot of data. I mean, my take on that is that let's say I come from a model-based school, right? So at the same time, I acknowledge the relevance, in a sense, of machine learning approaches. I believe that in the context of SLAM, machine learning makes sense when you want to replace one of the million heuristics that you have in the system. So there are a lot of heuristics for data association, for this and for that, and that makes a lot of sense to be like it's the field actually of its response to the correct problem. At the same time, SLAM is rather complicated. There's a huge state that evolves over time. So actually, I feel that an entire SLAM system in its full extent not. I wouldn't use only machine learning to respond to this question. Now, regarding the transfer learning to figure out potential places in maps, and I believe this has been already done in this line of research. So I think that there are references on that. And there are also approaches that, for instance, guess the depth of an image starting from depth of the pixels in an image, starting from an intensity view through training. They do the stuff, they do their job. They are excellent tools for, let's say, promising research-wise. I wouldn't control a robotic surgeon arm with the depth guessed by a neural network. Anyway.